put that in the Q&A section. It should be at the top of your screen. We do have someone on standby right now to be answering those questions. If there's a question relevant to the slide that we're talking about, we may stop and discuss that. Otherwise, we will have a question period at the end. If you would, please hold your microphone and keep that turned off until we get to that question section at the end of the presentation. Just so you know, we will be having a few polls throughout the presentation, so keep that in mind. It'll be pretty clear on your screen that we're having a poll. It should pop up. Feel free to answer that. There's no credit based on whether your answer is right or wrong, but it's just more informative and will help us to get a gauge on what the perception is in the industry. If you are looking for certificates of completion, these will be received via email within a week. And finally, we will be sending out the presentation via email following the webinar in case you'd like to go back, review any of the information we've covered. And of course, if you have any questions following the presentation, you can always feel free to reach out to myself or to Elena, and our contact information is right there on the screen right now. I guess one thing I didn't mention is that we are currently recording this webinar. Without any further ado, we'll go ahead and jump into it. So again, thank you so much for joining us today. This webinar for solutions for a corrosion-free sanitary sewer system. So to begin, unless you're intimately familiar with Geneva Pipe and Precast, I wanted to provide a little bit of background information on us. We have over 65 years of industry experience based out of Orem, Utah, with plants in Salt Lake City and Washington down near St. George. We provide a number of precast solutions and support throughout the design and construction phase. And we are really happy and proud to be a member of the Utah construction and engineering communities. Recently, we were purchased by Northwest Pipe, so we are now a national company with sister companies in water transmission, precast water infrastructure solutions, and Permalock casing pipe throughout the U.S. Today, the agenda for this webinar, there are several parts that we'll be covering with Elena and I transitioning as we talk through different parts of the presentation. First, we're going to talk about why we are doing this presentation at all. What is the purpose of corrosion-resistant products, and how does it play a role in our infrastructure, and what can we do about it? Existing solutions that have pros and cons in the marketplace, and introduction to some of the line products that we are excited to be introducing. Finally, we will talk about some of the questions in the discussion. So if you have any questions, again, feel free to add that to the Q&A or save them for the end where we can have open discussion. So jumping into it now, microbiologically influenced corrosion, also known as MIC, is a major problem in sanitary sewer systems where precast or cast-in-place concrete exists. Usually it flies under the radar, considering that most of this occurs underground, out of sight, in the dark. And so it's a natural reaction of chemical reactions. And because it flies under the radar, I wanted to point out that a lot of members of our industry, first of all, don't know what this is, and second of all, haven't been able to identify it. For example, this picture on the right here, where there's that weird kind of sloughing off stuff on the side of that manhole, that is a photo that I took just a few months ago after giving a presentation to a group of a group of employees of a wastewater agency. And in this presentation, which was much like this one, I asked, have you seen any of this corrosion occurring in your system? And they said, no, not at all, regardless of their system being over 80% concrete pipe. Following that meeting, we walked to a manhole that was less than 200 feet away from the meeting room where we had that presentation, and we popped this manhole cover. whereas you can see the concrete is peeling away from the walls. So this is very much a problem in our area and in our industry, um, as shown in that one experience. A few other photos of Mike that can cause catastrophic problems. Failing pipes, deteriorating manholes. Just look at that photo there in the center bottom of the ladder steps and what this corrosion might do to the reliability of those steps if someone was to try to descend that manhole and what might happen. Um, Not even nice to think about. So a little bit about the how of Mike and how does this happen? Where does this corrosion come from? As wastewater is conveyed, there's obviously organic and biological matter that continues to break down as it's transmitted through the system. Well, as this happens, the chemical reactions that are related to this degradation create H2S or hydrogen sulfide. As there's various factors that might affect the water, it will produce an airborne version of this gas, which will then eat away at the concrete. It will react with the chemicals inherent to concrete pipe or concrete precast structures, and with expansive internal reactions happening layer by layer, the concrete can slough off and fade away, leaving with a shell of what once was, or just failing infrastructure in general. So there are various factors that increase the likelihood of Mike affecting a specific pipe or specific structure. First of all, heat is a major factor. So in the southern parts of the US, there are certainly more instances or a higher likelihood of Mike being a major problem. Turbulence, so for example, lift stations, drop manholes, even steep changes of grade, but from across a manhole. Long transit time, so the longer that wastewater has to move down the pipe and that matter to break down, the more acid you're going to see. And finally, wastewater makeup. So one example of this was we had a customer who was ordering some pipe for a dairy, and the temperature of the water combined with the components of the wastewater meant that they were eating through concrete pipe very quickly, and so they needed alternative solutions to be able to maintain their infrastructure. Though it might not seem apparent, there are many, many impacts of what Mike does to us. So the first we've already talked about a little bit, infrastructure reliability. Um, you can have your pipes collapsing, manholes failing. If a manhole's failing, you've got increased I&I. You've got the possibility of sinkholes. There's public health concerns because if your wastewater is leaking into the groundwater, there's obvious impacts there. Safety, direct costs, and indirect costs, which we will talk a little bit more about as we move on. These costs, they are not insignificant, and we'll talk more about this in just a moment following a poll question. But these include, just like I said, the infiltration and inflow, the increase in water that needs to be treated, or even worse, exfiltration as it leaks into the soil, rehab, replacement, reduced service life, and finally risks of collapse. And as you can see from that quote there, it has been one of the most serious and costly problems facing global sewer systems. It is a major problem that we are facing as an industry. So, like I mentioned, here's our first quiz question. So once we get that launched, you should see a quiz pop up in the middle of your screen. Let that load, and here's the first question. How much money would you guess is spent on rehab and replacement each year? You have your options there to go ahead and vote. And once we have a significant number of votes in there, we'll take a look at the results. Alrighty. So it looks like we have how many attendees? 23 attendees at the moment. Um, we've got 13 responses. I'll give about another 10 seconds for a response. And again, you're not being judged on this. No, we're not recording who's voting what. This is more for us to gauge interest in or gauge knowledge of this problem and of these solutions in our industry. So with that, looks like the majority of people voted D, 14 billion, followed by 6 billion and 10 billion. The lowest option up there was $4 billion, and that is still a massively significant number, considering how much if we had if this wasn't a problem facing our industry, what more good could that money be doing if it wasn't to just replace products that could have a greater service life, greater condition, and so on and so forth. So with that being said, as we started to ask ourselves these questions, we wanted to find out what research has been done on the subject. Where can we find out what these costs are and their impact and their scale? How big really are the costs that this problem um, is requiring? We went online, we did research, we followed up with different studies and reports from all over the world. And as you can see there, the one that I'd like to highlight is the one from LA County, where it says in LA County, approximately 10% of the sewer pipes are subject to significant corrosion, and the rehabilitation costs are as high as 400 million. Now, LA County is the most populated county in the country by almost double, actually, and they have identified massive corrosion throughout their system. And as you can see through these studies from around the world in countries like Germany, Canada, China, this is a universal problem. It's not just one agency or one, pipeline or something like that. This is happening all over the place because it is a natural phenomena that we need to take care of, anticipate, and then uh, um, facilitate a resolution for. So that being said, as you can see from that quote on the bottom, there is 14 billion US dollars per year. So if you voted D on that poll, that was the correct um, answer, shocking as it might be. So if it has been such a shocking problem, such a massive widespread problem, and it's not new, it's not catching anybody by surprise, there have been attempts for quite a while to try to remedy this situation. Historically, there have been several options. So the first and most common that I think we see today is the use of inert materials. Second, and far less ideal, is the rehabilitation of failing infrastructure through relining or various other options. Another one would be coatings and sealants. And finally, modifying concrete makeup and batch mixes and things like that to create a modified or improved solution to product that is well trusted and has a great reputation in our industry. So to talk about each of these for a second, we've got our next quiz question for you before we really leap into that. So if we can get that launched, we will go ahead and do that. Alrighty. Okay, so this one says, when a pipe is determined to be failing or deteriorating due to corrosion, which of the following does your agency prefer for correction? So this is just an opinion kind of thing. Feel free to go ahead and vote. Looks like we currently have 27 attendees. So we will see what the makeup is. All right, we'll give it a few more seconds. I appreciate all of your participation. So we have about 2/3 of people voting. Alrighty, so with the results we have right now, it looks like the majority of people or agencies prefer realigning the existing pipe if possible. That makes sense. It's far less disruptive to traffic, to residents. If you're in a residential area, it is usually less expensive than full replacement. But as we'll talk a little bit about each of these options here, we will discuss the pros and cons of each. So the first of the historic solutions that we like to discuss are those of our inert materials. So the pros of these are that they are nearly impervious to corrosion. As proven, we've got various materials as shown on the screen there that are highly resistant to the hydrogen sulfide gas that eats away at that concrete through mic. Typically, they're lightweight and maneuverable. Sometimes they're customizable in the field, and they're typically lower cost per foot at the time of purchase. However, they are not without their downsides. These include greatly reduced structural capabilities. So our Mountain States Concrete Pipe Association, the past directors, both Jason Allen, Trevor McDonald, and Randy Wallen before them, have done a great job of going around the state and educating on the various ways that different types of pipes should be installed. And the great takeaway from these trainings is that there are highly increased installation times and procedures that need to be carefully practiced to make sure that these materials are able to support the load. Um, if these aren't taken care of, if these aren't done correctly, then you can have some of the problems as shown in the photos above of deflection, of settling. You've got they're much more pervious to damage, and as you can see, there are a list of reasons why these might not be suitable in all situations and might have greater risk than might be initially supposed. The next one to we're just covering these super briefly is the rehab and relining, which most people in our in attendance today seem to consider the preferred solution. So there are pros and cons. The number one pro is that there's no replacement necessary. So that saves time and money usually, it's less disruptive, like I mentioned. However, considering the fact that this had an initial installation, you're essentially just adding that on top of what that pipe was supposed to cost in the first place, increasing the life cycle costs. Um, Typically, as you can see in some of these photos, there's reduced system capacity, whether that's by decreasing the diameter of the flowable area of the pipe. There is potential for failure or delamination. Some spray linings can settle, and the expected lifespan is less than half of the structure's lifespan. Finally, one thing that I found interesting in my research was that some of the technology that is touted as a solution and has long-lasting lifespans has not existed for its advertised lifespan. So that's something to keep in mind as well. Um, Third, we've got coatings and sealants. The pros of these, and I'm not trying to say that these solutions don't have their place, but these so these coatings and sealings are designed to protect typically structure materials, precast concrete structures. They can be checked, for imperfections. Their thicknesses are adjustable. So if your agency wants a greater thickness to ensure that corrosion resistance, that's an option, several options to choose from. But the downside of this is that typically it is greatest and has greatest effectiveness for new installation. So as a rehab technique, this is typically not advised without extensive work of sandblasting and cleaning. And because of that, the time and the um, effort that goes into that, of course, in tandem with cost, increases this life cycle cost exponentially. It is high cost, it's slow, there are significant risks of failure and delamination, and there are some pretty bad horror stories about things just falling apart. And because a agency sealed it and they thought they were good to go, they didn't think to go check back. And when they did, Mike had taken hold once the liner had started to fail. Finally, we've got the material modifications, typically in the form of polymer concrete. So the pros of this are that it's based off of existing technology. It's based off of concrete, precast concrete structures and things of that nature. It's sold ready, corrosion-resistant product, drop in place, typically same installation procedures as your standard concrete precast structures, and can be used for custom designs or vaults or things of that nature. The downside is that it's typically not designed with reinforcement, and additional admixtures and modifications make these materials brittle or subject to various other problems that unmodified concrete doesn't see. There are, based on the minimum thicknesses when using reinforcement, typically you don't see as fragile structures as you do with the polymer concrete, just based on the standard thicknesses and compressive strengths. And finally, because these joints are not gasketed, leaks are common. So while you might think that you're protecting groundwater or things like that, you could actually be very well experiencing exfiltration unknowingly. Finally, it is a pretty expensive option. So let's get into what could be a perfect solution. So the best parts of several of the options that we've already discussed are that the inert materials are inert, and where their weaknesses are in their structural capabilities. There was a plan many years ago to develop a hybrid of sorts of a lined concrete pipe, which both prevented the concrete from experiencing the corrosion associated with hydrogen sulfide gas, while also providing the strength and structure of concrete pipe as trusted. So back in about the 1980s, this product entered the market, but there were downsides to it because it required in-field welding, manual entry and access. It was slow, it was time-consuming, it was expensive, and it was absolutely infeasible at smaller diameters, which kind of led us into the product that we would like to introduce to you today. So at this time, I'd like to give the floor over to my co-presenter, Elena Mikolova. Elena, take it away.
Hey, thanks, Brandon. Thanks for great background information, Brandon. And I'm gonna be introducing our products, talk a little bit more about the application, how we make it, and the quality of the product. So this, the picture that you're seeing here, it's the photo of our perfect plants. So as you can see, we have various sizes on site that we can make our line products, and I'm talking about both line manholes and line pipes. So the system consists of, the entire perfect line system consists of a perfect pipe and perfect line manhole. So the perfect pipe, it's basically your traditional ASTM C76 RCP, but it's also lined, and it also has innovative connectors that we haven't seen in US market before. So this is something that was invented in US, and Geneva Pipe was part of the solution and brought this technology over to US. So the availability of these pipes are anywhere from 24-inch all the way to 60-inch. So this is dictated now by the availability of the equipment who manufactures for this type of pipes. The length of these pipes are a little bit longer than traditional storm pipes that you're used to seeing. It's about 10 feet long. And as you get closer to the manhole, so you've got to adjust the length of the pipe. Instead of cutting it in the field, we can manufacture shorter sections so you don't have to cut, and you can still reuse this coupler. You can see the black coupler on the screen. So you can seamlessly connect pipe to the manhole. And these pipes are good not just with the perfect line manholes, but they can connect to any other existing manhole in the field or the new manhole in the field. And you can utilize the connectors with the manhole. So let's see, if somebody's manufacturing manhole, we would provide the connectors so they can cast it into the manhole. So our pipe, perfect line pipe, can connect to that manhole. And the right in the middle, this is a photo of the line base. So this is also part of the solution that we offer for the manholes as being corrosion resistant. So the beauty of this line manhole, as opposed to, let's say, a liner with epoxy spraying, it's the same material, concrete. It's also conforms to all the ASTM C498 requirements of the H20 OHL 93 requirements. Plus, it has a corrosion-resistant liner that is cast into the manhole during the manufacturing process. So this is a composite monolithic structure that will never peel off, as opposed to epoxy liner protection. The joints of this manhole also feature gaskets. So, and these manholes have been tested for the pressure, so they're fully watertight and corrosion resistant systems. And the availability of these manholes are anywhere from 48 all the way to 96 in a gasket. If you want to have it larger, then it has to be field welded. And I know that for weldless solution, it can be a huge difference maker, because you don't have to spend that time and the cost on welding the joint, making sure they are welded properly. So let's talk about perfect pipe. So here you can see the photo of perfect pipe, and you can see there are penetrations in perfect pipe. So it is possible. Lots of the questions come in from the engineers. Can this pipe be penetrated with laterals? The answer is yes. It can have laterals, and there are special connectors that will seal the surface in the core that have been drilled through the pipe. The laterals normally made through the outside with the drilling core, and then the connectors also installed from the outside. These pipes also have a special recess by the bell and by the spigot, so we can install those black couplers, so you have seamless installation between the joints. Let's look at the anatomy of the perfect pipe. So this pipe consists of the RCP, the traditional ASTM C76 pipe, and plus you have embedded liner into the pipe. So this is a monolithic or composite action that's pipe is showing. So it has a strength of the pipe and the corrosion resistance of the HDP liner. And HDP liner is one of the top materials that you can have for corrosion resistance. And plus it's also abrasion resistant material. And of course, the couplers, they normally factory installed. So if you order a pipe, we would install it before delivering it. So it takes away from the contractors having to install it. All they have to do is to just lubricate the joints and push the pipe together. And this coupler it has two double tilting edge gaskets, which seals from the spigot sides and from the bell side. And you can see these are the anchors on the liner, on the yellow liner. You might have been familiar with the products made by Agro, like Sure Grip. So this is a similar material also manufactured by Agro, but it was specifically designed for perfect pipe. So the anchors, as compared to the other liner, Sure Grip, are a little bit smaller, but they're more densely spaced. And this type of liner is made for production with a self-consolidating concrete, as opposed to Sure Grip was made for dry cast or regular wet cast concrete. Here's a photo of our facility. Each liner goes through the welding with a gun, and then each weld before we put it into the form to pour with concrete is tested for any defects. And at that point, no liner would go into casting without being checked. So this is we have very tedious process of quality control for our pipes, including the measurements of the liner and the weld checking. And after that, it gets cast into concrete. So this is the photo of the guy testing the liner. Then the liner goes on the expansion machine. So we need this machine. It heats up the liner and expands the ends of the bell and the spigot. So this is the recess point where your black coupler would go as a part of the joint. So for these pipes, you don't really need to do any welding either for when you install. So that saves on time and installation cost for the agency, for the contractor. And here are the images of how we prepare the liner and the cage right before it's being poured. In the left-hand side, right over the liner, we'll put the reinforcements. And once the reinforcement is in, we do the quality checks to make sure reinforcement is in place. And it covers all the joints and spacing is correct. So then we're close it off and pour concrete. And the next day we strip the pipe and do the quality checks to measure everything else that is needed. So the major benefits, you're getting the strength and structure of concrete, right? And everybody's familiar. The expected life or service life of concrete is over 100 years. Plus, now the concrete is chemically resistant because of the liner embedded into concrete. Then superior joint performance. The major concern with the agencies in the past about the related to RCP is the joints. Joints don't perform, they leak, they move. So this pipe resolves all the issues that like regular RCP has for leaking or having to weld the HDP liner. It is familiar to the contractors. Contractors may have never seen the perfect pipe. However, they've seen RCP, and this pipe is installed just like RCP because it is RCP. And the major advantage of these pipes, it eliminates the field welding for most diameters, right? So if you have a pipe of 24 or 36, even 42 inches, it's really difficult for the human to go in the pipe and access and weld. So the contractor will have to have somebody tiny and experienced. But with these pipes, you don't need to go inside the pipe, and also it eliminates the risk associated with the confined spaces. So it's a huge advantage in cost and time and risks of installation. And these pipes can also be used in trenchless installation. For the trenchless, we would just add a little bit more reinforcement to the joints and steel bell bands so you can push it through in a jacking application. Now let's talk about perfect line manholes. So these are the photo of the perfect line manhole and the form that is the perfect line manhole made with. So the background, this technology was developed again in Europe by the guy called Manfred Prudl. He's in Germany. And these manholes spread like fire in Europe. They've gotten adopted by the agencies because the agencies saw the value and they started replacing all the older manholes with the line bases, line risers, basically perfect line manholes. There are all over 200,000 line bases have been installed in North America alone. That's I'm counting Canada and US. And Geneva is the only manufacturer at the moment that produces perfect line manholes. That means the full solution, the bases line, the risers lines, and the lid lines, and it has a seamless joints where you don't have to weld the liner between the sections. It has a gasketed joint, and the manhole has been tested for the pressure to make sure it was leak proof. So here's the kind of like a breakdown of all the benefits of perfect line manhole. We also have a warranty of 50 years against corrosion in these structures. So as you can see, the base is lined, but it's lined with FRP or fiber reinforced polymer. It is not easy to line the complex structure or the complex configuration of the base because you have all these turns and troughs and channels. And so we line it with FRP. And then we have risers that are lined with HDP. You saw in the previous picture when I was talking about the pipe, it's lined with a perfect liner, HDP liner. We have lots of anchors in it. It's also embedded into the walls of the manholes. So the manhole joints has a compression rubber gasket seal. So when the contractor puts the gasket on and puts the next section on, it compresses and distributes the load of the section evenly. So you have a nice tight seal in that manhole. This manhole also cast with monolithically. So you're not going to have any cracking in between the walls and the bottom slab. And it's cast with a self-consolidating concrete. And again, the huge advantage is that no welding is required, so you don't need to have anybody inside when you install on these structures. So you just put the sections like a regular manhole and you'll be done. Again, the same liner as we use for perfect pipe. It's a highly abrasion resistance liner. We have it in different thicknesses. Our perfect line manholes are manufactured with a 2 millimeter thickness. However, if need be, if you require higher back pressure, for some reason, if you have deep installation with high groundwater, we can manufacture it with a 3 millimeter or higher thicker liner. Over here, you see how we make the liner. So basically, we make a negative mold and of the channel, and then spray it with fiber reinforced polymer or plastic, and then we attach these black little parts. It's called bonding bridges. We attach them to the liner, and then they're going to be cast and hold that liner embedded into concrete. It also has liner features built-in connectors for different types of pipe. So if you have specific pipe, let's say SDR35 or DIP, we have specific connectors that can fit that pipe. In the photo on the right, it's one of our first projects, which was made in Utah. So another image showing how we manufacture those liners. So basically we spray the negative mold with the FRP. Once that mold is completed, we place it in a form with the, then we close it off and pour concrete over. So then we flip and your base is ready. With these manholes, we can do technically any configuration. We have a robot that cuts the channels or the negative form to any configurations. If you have 3-way, 2-way, 8-inch, 10-inch, we can make it all to whatever your imagination is. A little bit of testing background. So this testing has been done on existing installation. After 20 years, one of the manholes were dug out. They just wanted to see how the liners perform, if there's any deterioration between the line behind the liner. I don't know if anybody's familiar with the T-lock. T-lock used to be one of the popular choices, and it still is, especially in the state of California, where agencies would choose T-lock, and it's a PVC liner. And after some time, 20 years, 35 years, they will go back and they do find corrosion behind the liner. The most likely reason is because during the welding, it has not been welded through properly, and you probably had some defects in the welding where your environment could still penetrate through the liner and behind into concrete and create corrosion. But anyway, if you're looking at this cutout, so they dug out one of the bases and they cored it, and they wanted to look at the thickness before and after, and they did not see any deterioration in the liner, and they did not see any corrosion behind the liner. So this is a great indication that this liner works, and it can seal and protect concrete for years. And this is to the point where I was saying that we can manufacture any configuration. This is an example of one of the projects that we did last year in Utah, and we had to manufacture a 96-inch line base. So on the left-hand side, this is a liner in the preparation stages, right before it being cast. And this on the right-hand side, this is the base of the line base of the manhole. In this case, agency chose to have only base to be lines, but the risers were not lined. And we see that very often. But one thing you have to remember that the microbial induced corrosion happens in the air, not where in the trough zone for the most part where you have the flow, but because of the suspended particles from the wastewater. So most likely you're going to have a deteriorating walls rather than deteriorating channel. So with this, I'm going to pass it down to Brandon, back to Brandon. And we're going to launch another quiz question.
All right, thank you, Elena. All right, so it looks like that poll is on screen right now. Which of the following is not true about perfect lined manholes? Elena just did a great job of going over those, so of course everyone will get this right. Let's see. As these keep coming in, we've got a couple of responses. We've got 32 attendees right now. So we'll give it some time for people to start answering that. All right, so emphasis on which of the following is not true about perfect lined manholes. So manhole bases come pre-channeled. Manhole bases are lined with FRP, while the risers are lined with HDPE. The manhole bases are exclusively compatible with perfect pipe, or each joint in the manhole is gasketed. Alrighty, so we got 13 responses, 14, they're still trickling in. Feel free to keep voting. The answer to that one is C. Manhole bases are exclusively compatible with perfect pipe. These manhole bases, as Elena mentioned, are compatible with any diameter, any pipe material, any slope, any configuration. Again, as Elena mentioned, we have a robot in our facility that can cut foam negatives into any configuration or shape necessary. So these manhole bases are fully customizable. The things that are true are that the manhole bases do come pre-channeled. They come ready to drop in place and connect with your pipes. The bases are lined with FRP while the risers are lined with HDPE, and each joint in the manhole is gasketed. So thank you for your participation there. Moving on, I wanted to mention a little bit about some of the tests that have been done for these products. So the first was a hydrostatic test for exfiltration. So as we mentioned earlier, one of the risks with failing infrastructure is that you can affect groundwater pollution levels. So if you have a pipe that's starting to fail and you see any leaks and your wastewater is getting into the groundwater, there are very, very serious health concerns with that. So in considering this product that Geneva was willing to put their name and their reputation behind, we wanted to make sure that these tests would stand up to our industry standards and something that we could really get behind. So in this test in particular, we held a positive pressure for 20 minutes at 60 PSI, which these pipes, to be clear, are not pressure rated. We are not recommending these for pressure sewer installations or situations. This was simply to know that if we get head in a manhole somewhere upstream, is like, what can this thing handle? This was able to handle 60 PSI, which is a whole lot more head than we're going to see in normal installation or in a normal project. Secondly, we wanted to test for infiltration. So another cost associated with failing infrastructure is the increase of water that needs to be treated. So this one, it's kind of hard to see, but there in the right photo, we drilled a hole through the bell of one pipe joint, and we introduced a positive pressure behind the coupler. So to test those gaskets to see what they could hold. These held at over 30 PSI for 20 hours, which again is a lot of head, more than you will see in most typical installations. Beyond that, we wanted to make sure that not just the coupler, but also the liner itself. So for some reason, if any water pressure was able to get behind that liner, how would those anchors hold up to it? Well, I don't remember if Elena specifically mentioned it, but each one of those anchors holds, I believe, it was, I can't remember what it was. I think it was over 100 pounds of pull-out force per anchor, with over 100 of these little anchors per square foot. So right there, we had 30 PSI for 200 hours to see how those anchors would perform, and it was able to hold. Of course, as Elena mentioned, this technology was initially developed over in Europe, so there have been extensive tests done over decades of service. As you can see there, there are various, so you don't see ASTM on there for the standards, but these different standard organizations are for the European Committee of Standardization, equivalent to our ASTM standards. So they've been tested for chemical resistance, abrasion, tear out strength, outside water pressure. Some more here, high pressure jet resistance for when you go through and want to clean and pressure wash the interior of your system. Sorry, pipe connection seal, and various other tests. Here are some more as well, but let's move on to our final quiz question. If we can launch that. And I really wanted to save some time for questions, so I'll try to speed through the rest of my section. All right, which of the following is a benefit of perfect pipe and perfect line manholes? So go ahead and submit an answer there. And we'll try to go quick on this one just to save some time. Alrighty, we've got 8 responses right now. We still have 30 attendees, so we'll wait a second to get a few more. And I like what I'm seeing. A lot of people are getting this question right. I've had more success on this one than some of the others, so good job reading through those options. Yes, if you haven't already voted, the answer is E, all of the above. All of these various features and benefits of this product line are real and can help prevent your infrastructure from failing prematurely. Thanks for voting for that. So I wanted to highlight just really quickly a couple of projects that we've done in the last year in here in Utah, where we're based out of. So this one was the 950 North Sewer Trunk Line for a sewer district here in Utah. This one was interesting. There was a major transportation corridor coming in, and the service district knew that if they were to put this pipe in ahead of time, it'd be a lot cheaper to put that in before the highway went in. But they also recognized that if that pipe was ever to fail, it would be enormously expensive to replace or repair or whatever they would need to do. So the project was bid with 4 different pipe materials. There was PVC, HDPE lined RCP or perfect pipe, non-lined RCP, and then FRP SN72, which some of you may be familiar with. The reason that the perfect pipe was chosen for this project was, one, due to its durability. There were great installation depths. Well, there were over 20 feet of installation, but the real reason why they were so impressed with this product was because of the high groundwater. At that depth, there was groundwater almost to the surface, and they needed something that would be able to resist the infiltration and inflow. And so they went with this product for over 3,400 linear feet of sewer pipe. The next one that I'll just briefly cover was a jacking job that we did for the city of Logan that went under UPRR right-of-way. So that one was particularly interesting because, as some of you may know, typically if you were going to be crossing railroad right-of-way, you need a casing pipe and then a carrier pipe. For this product, it was approved as an all-in-one solution as both carrier and casing for sewer, which is very unusual. Typically, you would, I'm not aware of any other projects like that. So this was an exciting one for us to do. The background was there's just over 100 feet of sewer pipe from one edge of the right-of-way to the other because the railroad wanted something that would be corrosion resistant and durable. A couple of manholes that Elena showed previously. Yeah, that's finally the benefits of this as a trenchless installation are that, again, you have minimal disruption. You're not tearing up the road. To tear up a railroad crossing would be incredibly problematic and expensive and time consuming, and in reality probably just would never be approved. So this solution was very exciting for us. That being said, I will turn the time back over to Elena to discuss a couple of up-and-coming solutions, and then we'll get to our question period.
Hey guys, good to see you again. I just wanted to briefly tell you about that our company is not just producing line manholes and line pipe. We also have other solutions that are suitable for new construction and rehabilitation, and one of them is PVC line manhole. Over here, you see this is not a line manhole, but this is one of the solutions. If you have existing sewer, this is just show that we can make the liner and put it on top as a saddle. So and put the riser on top of this, so you can have a continuous system without having to cut through the pipe or disconnect the pipe. So this could be one of the solutions. Another one is a PVC manhole. So it's almost the same as line perfect line manhole. It has the basis lines in. As a riser, we use the PVC. This solution can also be used for rehabilitation work. So what we would do, if you have, many of you indicated that you guys prefer, your agency prefers to do rehab work rather than new construction or replacements. So this solution could be suitable for existing manhole when you want to rehab. So we have a scanner that would go inside your existing manhole and will scan the geometry of your manhole with all the imperfections and cavities, and we will determine your existing configuration of the channel. And based on that, we can make the liner that can fit into your existing base. And then the walls of the manhole can be protected with a PVC riser. And this product has been tested and it conforms to H20 or HL93 load. And it has been used and installed in some of the agencies throughout US, but this is still a relatively new product. So over here you see installation of it. Lots of agencies choose to have a pilot installation, see how that works. Another product of ours is FRP panels. It's also for the rehab work. The same way we would do as with the manholes, we would scan it with our scanner, which will determine your exact configuration of your vault or manhole or the box. And we can make the FRP panels and assemble them in the field. And so they're going to have seamless connection between the panels and the water resistant and corrosion resistant. So this is an example of the image that we would get using the Ferro scanner. And once we process the existing condition of the manhole, we can recommend that we can manufacture or make the solution for rehabbing the structure. All right. I think we're at the end, and I would like to welcome any questions.
Yeah, at this time, feel free to unmute yourself if you have a question. Unless we have too many at a time, then we'll maybe go to the raised hand option. But if anybody has a question, go ahead and go for it.
Would we be able to get a copy of this presentation?
Yes, we will actually, if you registered with your email address, I believe that we will be sending this out to all the email addresses that registered for this event. If not, feel free to reach out to either Elena or myself at the contact info on the screen.
How about lead times?
So are you referring to the pipe or the manholes or just both in general?
Both in general.
So Elena, do you want to take that one?
Yeah, sure. So the lead times for the pipe, I know lots of you probably have experienced the long lead times on storm products. Lots of manufacturers have backlogs because of the supply chain issues that was created during the last couple of years. I wanted to emphasize that our line products has a separate facility independent of other products, separate from the stormwater products. So pipes are readily available. So if you wanted to specify, we have the sizes anywhere between 24 through 60. The manholes, the lead times right now, anywhere between 4 to 6 weeks. And it depends on the season, right? If we get to this heavier season, then our lead times can get longer, or if we get slow season, our lead times get smaller.
Thank you for those questions. Any more?
All right.
All right. Again,
Yes,
thank you so much, all of you, for attending and registering. Again, we will be sending out a copy of this presentation, but feel free to reach out to Elena or myself if you have any other questions that come up at any time or any interest, or if this was a presentation that you found valuable and you'd like your team to receive a similar training, we'd be more than happy to schedule either a virtual or in-person presentation. So just feel free to reach out and we'll be happy to get that on the books.